So good afternoon everyone and welcome to this lecture. We are in Newton's law of motion and we are discussing the motion of bodies which are connected. In the previous class, we had seen some examples of bodies connected with each other and we had found out their accelerations. Yes or no? Do we remember this? Now, up till now, what was happening was that we had bodies which were connected to each other only using one single string. Now, when they were connected to each other using one single string, acceleration of all the blocks were same. They might have been in different directions, but magnitude wise, all the accelerations were same. Yes or no? Yes or no? Okay. On that
Yes,
front,
sir.
only one type of thing is left. Why should I leave it? Once you have done this, you can also tell me the answer for this one. So before going on further, let us do this one as well. Why should I leave anything when we are doing everything? So this is the last of that category. And let us first do this and then move ahead. Again, here we have two wedges inclined at different angles. One is alpha, one is beta. Two blocks of mass m1 and m2 are put on those wedges. Now, can you tell me which side the block will go, and depending on what the block will move on which side? I mean, the motion will happen on which side? It depends on what. We have one block m2 on one side. The angle of inclination, as you can see, is beta. We have one block m1 on the other side. The angle of inclination you can see is alpha. Which way the system will go and under what condition it will go? For example, they are saying in the diagram that the system is going on the other side, the side of B2, the side of M2, sorry. M2 is coming down. When will this happen? When will the block M2 come down and M1 go up? And when will M1 go down and M2 go up? Can anyone tell me? Do you understand the question? Yes or no? So, what is the answer? They have given that M2 is going down. What is the condition for M2 to go down? When will M2 go down? When will M1 go down? No one knows the answer?
Weight of M2 is greater than weight of M1.
No, that is not the case. Weight of M2 is greater than weight of M1. That is not the case. Think again.
Inclination, sir.
Not inclination and not weights singularly. When will M2 go down and when will M1 go down? Yes.
Components weight.
Component weight. So tell me now why you are saying component weight. You know what is the weight. You tell me. Under what condition M2 goes down and M1 goes up? And under what condition M1 goes down and M2 comes up? Yes. Tell me first. No one knows. No one knows it. No one knows it. Okay, then I'll solve it. If no one knows it, then there's no point of waiting. So if I draw the free body diagram, This one will be M1G. This will be M1G sine of alpha. This will be M1G cos of alpha. And this one will be normal reaction N1 on this side. This will be M2G. This will be M2G sine beta. This would be M2G cos beta. And this one would be N2. As you can see, it is not going to move along the plane, perpendicular to the plane. So N2 will be equal to M2G sine, M2G cos beta, and N1 will be equal to M1G cos alpha. So we know this. Now, what do we see? The force which is trying to pull it down on this side is M2G sine beta. The force which is trying to pull it down this side is M1G sine alpha. Which side will it go? Will it depend on what will it depend on? M2G sine beta is trying to pull it down from the other side. M1G sine alpha is trying to pull it down from the other side. Which side will it go? Will depend on what? Yes. Yes. Can't hear you. Anyways, I will imagine that you understand. It depends on who is greater. Is if M2G sine beta. Let me write it. If M2G sine beta, the force on this side, is greater than M1G sine alpha, the force on this side, it will go in this direction, and which is what I have written. It is going down. That means M2G sine beta is greater than M1G sine alpha. Once I understand this, I can straight away write the acceleration of the body. What will be the acceleration of the body? M2 sine beta minus M1 sine of alpha multiplied by G divided by M1 plus M2. That would be the acceleration of the blocks. Now you can make any one of the equation of the block, whether of block M1 or block M2, and you should be able to get the value of this T or this T because both the T's are same. Do we understand this?
Yes, sir.
What was so difficult in this? So the same question as what we had done. We just had to compare which force is trying to pull it this side and which force is trying to pull it on the other side. It will go on the side where the force is more. Here we have assumed that M2 sine beta is more than M1 sine alpha. It will go on this side. If M1 sine alpha would have been greater, it will go on the other side. You told me it depends on M1, M2. No. You told me it depends on inclination. No, not separately. But when you combine the two, multiply M1 by sine alpha, multiply M2 by sine beta, that component, if it is more, it will move on that side. I will give you 1 minute to note it down. I hope everyone has noted it down. Everyone has noted this down? Yes or no? No, yes. Okay. Now we come on the next topic, which is known as constrained motion. What do you mean by constrained motion? Right? I am writing E. Constrained motion. What do you mean by constrained motion? When I say constrained motion, constrained, the word in English means restrained, restricted motion. Now, as you can see, bodies are not free. We have seen the motion of different bodies. Sometimes the body was kept on an inclined plane. Sometimes the body was kept on a horizontal floor. Sometimes the body was hanging. In all those cases, we saw that body just cannot move anywhere freely. A body kept on an inclined plane just cannot fly off like this. It is restricted to move on that inclined plane. That is known as the constraint motion or restricted motion. Now, there are two or three types of restriction that you have to understand. One of those types we have already dealt with. That is known as the plane constraint or the wedge constraint. Plane constraint or the wedge constraint. Now, what do you mean by this plane constraint or the wedge constraint? If you have a body which is kept on a horizontal floor, unless otherwise stated, if I apply a force F here, we understand that this body is not going to fly off. This body is supposed to move along this plane. It cannot move perpendicular to the plane. If I apply a force like this, it cannot go inside the plane. It has to move along the plane. You can call this as the plane constraint or the wedge constraint. Similarly, if a body is kept like this on an inclined plane, you can call this inclined plane as a wedge also. If I keep a body here, and we have seen that case where this inclined plane was smooth, the body was not supposed to fly off. It could not fly off. The body can only move along this direction, along the inclined plane. It cannot move perpendicular to the inclined plane. That is what I call plane constraint or wedge constraint. Do we understand this? It has gone above our heads, saying bye bye. So this is as simple as you say plane constraint or wedge constraint. Now I can make some what should I say? Some revolutionary diagrams to make you understand the plane constraint. For example, this is ground. This is a wedge which is kept on a ground. This is another wedge, triangular wedge kept on a ground. Now these wedge can move. They are not fixed. Now I have one rod kept like this in contact with these wedges. There is no friction anywhere. There is no friction anywhere. And I leave this system. Can it move in any random direction? Can the system move in any random direction? Which direction this system can move? If I talk about this wedge, the pink wedge, where can this pink wedge go? Where can this pink wedge go? There is no friction anywhere. Where will this pink wedge go? Can it go anywhere? Where is this? This is not physics. This is common sense. Where will this pink wedge go? Left, right, up, down, like this, like this. How will it move? Yes. Where will this pink wedge go?
Left, sir.
It can only go left. There is only one way it can go is go left. See, it is constrained to move. It cannot just move anywhere. Where will this green wedge go?
Right.
It can only go towards right. There is only one way of this possible. Where will this blue rod go?
Downward, sir.
It can only move in the downward direction. This is what I call plane or wedge constraint. They are constrained to move. They are in contact with each other. They just cannot move in any random direction. Random direction they cannot move. Do we understand this? I can give you one more example because this might come as question sometimes. All these are plane constraints or wedge constraint. Again, I have a wedge like this, and I have a rod kept like this. but this rod is kept under a rail. So there are two vertical columns like this. Now again, I leave this system. There is no friction anywhere. Where can this blue wedge, this pink wedge go?
Left.
It can only go towards left. What about this green rod?
Sir.
Where can this green rod go?
Downward, sir.
It can only go downwards. Plane constraint or wedge constraint. Because they cannot go anywhere. They are restricted. This green rod is restricted by this rails. This rail is not allowing it to go here and there. This rail is allowing it to only go in one direction, vertical. It goes in one vertical direction, downward. This has to move here. It cannot go anywhere else. So all these are examples of what? All these are examples of what?
Constraint, sir.
Plane or wedge constraint. All these are examples of plane or wedge constraint. Bodies are not free to move. They can only move in one particular direction, depending on what are they are in contact with, which plane or which wedge are they in contact with. That is known as a plane constraint or a wedge constraint. We've already seen examples of this plane constraint or wedge constraint, and that is why we started with this. We had seen the example of this. We had seen the example of this. In fact, wherever we saw in the previous thing, this was also an example of plane constraint. Yes or no? M2 block can either move, go down like this or go up like this. This was again an example of wedge constraint. This was again an example of wedge constraint. The M1 block can only move down. There is no force on the other side. The M1 block can only move down. The M2 block can only move towards right or left, whatever you call it. All these are examples of plane constraint or wedge constraint. Do we understand this? Yes or no? Now, apart from this plane constraint or wedge constraint, which M1 and M2 are subjected to, M1 is kept on an inclined plane, M2 is kept on a horizontal plane here. So they are subjected to plane and wedge constraint. But apart from plane and wedge constraint, they are also constrained by one more thing. They are also constrained by one more thing. What is that other thing that you see because of which they are moving as they are moving? They are also restricted by one more thing. Apart from this plane, that they can only move along the plane, they're also restricted by one more thing. What was that? That was the string, my dear friend. They were connected by a string. So that also restricts their motion. For example, if M1 moves down, M2 cannot go on that side. M2 has to come on this side only because they are connected by a string. That is the next constraint. And the next constraint is known as what? Huh? String constraint. String constraint. Now we have dealt with this string constraint from the very first question that we did on strings. On the very first question that we did on strings, we were dealing with this string constraint because as soon as we heard the word string, I gave you some important points about strings. Do you remember those points about the strings that I had given you? See here. This was the first time we saw any string coming into the picture, and I told you when two blocks are attached to the same string, they have the same modulus of displacement, velocities, and acceleration. They might have different directions of acceleration or different directions of velocity. As in this case, block M1 is moving downwards, block M2 is moving rightwards, but they have the same magnitude of displacement, same magnitude of velocity, and same magnitude of acceleration. So we have already seen this string constraint. This is what I call string constraint. They are attached to each other by strings. They just cannot move. They just cannot move freely. Yes or no? Any question that we did on string, consisted of the string constraint. This question, how many constraints were there? There were two constraints put here. What were the two constraints? One was the plane constraint, because this block on the inclined plane can only move along the inclined plane. So plane constraint was there. Then there was string constraint, depending on which is more, M2 G sine theta is more or M1 G is more. Here we had taken, I think, which one? Okay, this was a question of equilibrium, I think. This was a question of equilibrium. Depending on which is more, we had seen that the system can only move in one particular direction. There also we were using string constraint. Do we understand this? There also we were doing string constraint. Here in this question, again we had put two constraints. One was the plane constraint on block M1, but block M1 and M2 are not free to move. If M2 goes down with acceleration A, M1 has to come forward because they are restricted by the string constraint. They are connected by strings. But up till now, whatever questions we were dealing with, we had only one string. Here we had two strings, but they were connected to a single block. So it was still a single string problem. Whenever we did any problem, this one or the last or this one, the two blocks were connected by a single string, or this one, two blocks were connected by a single string. The string was going up and down somewhere, but they were still connected by a single string. This block, the last one that we did, again they were connected by a single string. So when they were connected by a single string, no problem, because whatever one has moved on one side, the other should move on the other side depending on how the string is moving. But what happens if we have two blocks connected by two strings? Are they still free to move? Are they still free to move? Let me see if I can get a better diagram here. Else I will have to make my own diagram. I'll find some diagram. Not there. Then I will have to make my own diagram. I'm not getting a diagram. This one you will get confused. This one more confusing. So I'll make my own diagram, and to make you understand how they can have one string is here, one pulley is here, one mass M1 is here. This is the simplest diagram that makes us understand this concept. Oops. This takes time to draw the diagram, and I don't want to waste any time. Okay. Now this is the diagram, and I think we have done this question before also. Now, if you can see here, the situation has somewhat changed from the previous questions. In the previous questions, we had only one string which was moving around here and there and connecting to each other. Here, how many strings do you see? Now, if I talk correctly, this is string number 1, and this is at least string number 2. And depending on how this pulley is attached, it could be a string, it could be a fixed joint, doesn't matter. That these two blocks are now not attached by the same string. They are attached by different strings. Do we see this? Yes or no? They're attached by different strings. Now, since they are attached by different strings, but those strings are again forming a system, they are interconnected to each other in some ways. Yes or no? Do we see these strings connected to each other in some ways? Obviously, these strings, though not connected physically, they are connected to each other through the system. That means these blocks are still not free to move. These blocks are still not free to move. They can only move depending on how this connection is made. Do we understand this? Yes or no? Now we also understand this. Both of the blocks cannot move down. Yes or no? Depending on who is, depending on the condition of which is what, the blocks are going to move in their way. Let us assume, I don't know where it's going to move. So let us assume that this moves down with x2. If this one moves down with x2, what will happen with m1? Will it move up or will it move down? It has to move up because there is no physics involved here. This is just common observation that if one moves down, the other has to move up. Now, the thing here is that this x1 and x2 are not going to be same because they are not connected by the same string. So we'll have to find out the relation between x1 and x2. We have been doing that from the very first day when we did problems on string, but then the problem was simple because they were connected to the same string. But now the problem becomes a bit more different. I will not say difficult. It becomes a bit different because now they are not connected by the same string. Now the question is, how will I find the value or the relation between x1 and x2? Whatever is the relation between x1 and x2, in this case, same will be the relation between v1 and v2. Do you understand what the meaning of v1 and v2 is? v1 is the velocity of the first block upwards. v2 is the velocity of second block downwards. The same will be the relation between a1 and a2. I am drawing it downwards. If I get the relation between x1 and x2, that will be the relation between v1 and v2. That should be the relation between a1 and a2. How do I get it? Now I will not go much into the detail of this, how we are going to do this. There are 2 or 3 different ways of doing it. We don't have enough time and we don't want to waste time as well. Remember, JEE is all about saving your time. It's not about telling you 15 ways and then I'll tell you this is the best way. So why to tell you 14? Just tell you the one which is the best. Okay. So how are we going to do this? We are going to do this by a principle which is known as the virtual work principle. You don't have to even know this virtual work principle, but just for your academic purpose, even it is not for your academic purpose. This is just something that you know. We are going to do it by something known as a virtual work principle. And what does this virtual work principle say? Now this tension in the string, if I consider this entire system as one, this block, pulley, if I consider this as one system, these 2 blocks and this pulley, this tension is an internal force. Do you understand this? This tension is an internal force, and whatever tension is getting applied on one body, the same tension is going to be applied on the other body in the opposite direction. Yes or no? So basically it says that this work done by this tension force, which is the internal force, is going to be 0. The work done by this tension force is going to be 0. Now we don't know what is work done. Okay, we have not seen what is work done. So we'll have to first understand what is work done, because otherwise we cannot go ahead. We'll just understand work done by a force. Anyone knows what is the work done by a force? Ninth standard work done. It is actually integral of f dot dr, where F is the force and dr is the small displacement. And there's a dot product over there. This is the actual formula. We'll not go much into the formula because there's an entire chapter after this chapter, which is work, power, and energy. We will go there. But I can't tell you the wrong definition, so I have to tell you the exact definition. This is the definition of work done. Here, this force is going to be constant. So for constant force, when the force is constant, the formula for work done becomes F vector dot with your displacement vector. Or I can very seriously write work done is a scalar quantity. So it is work, force into displacement into cos theta. Where what is this theta? Theta is the angle between force and displacement. Do we understand this? Theta is the angle between this force and displacement. So work done is F into displacement into cos theta. Similarly, if I want to find out the power of this work, power is the ability to do the rate at which work is done. Power will be given by F into V into cos theta. It is a derivative of this thing. So derivative of your position vector becomes V. So power becomes FV cos theta. So either we can use equation number 1 or we can use equation number 2 to find out what we are supposed to find out. We are supposed to find out relation between x1 and x2, v1 and v2, or a1 and a2. Now what we are going to do is use this virtual work principle. Work done by tension is going to be 0. Now let us now come back to the problem itself. What was the problem? Now in this problem I had two pulleys. One is the yellow pulley and one is the blue pulley. Do you see this yellow and blue pulleys? Now this yellow pulley does not go anywhere. This yellow pulley is at rest. Do we understand this? This yellow pulley is not going anywhere. Yellow pulley is attached to that ceiling and it is at rest. We understand this? This yellow pulley is at rest. We don't have to worry about this yellow pulley. What about this blue pulley? Is it at rest or is it moving? This is not a problem of physics. This is a problem of common knowledge. Is this pulley at rest or is this pulley moving? This pulley is moving. Yes or no? This pulley is in motion. This pulley is moving. This pulley is also accelerating. But remember, we have assumed that what? That the mass of this pulley is 0. So it is not going to make much of a difference to our eventual analysis. Now, how do I do this? I have to find the work done by tension. So first of all, I have to draw tension in all the strings. Now, how do I draw tension in all the string? Let me call this tension as T. This tension is T. This tension is T. This tension is T. This tension is T. This is one string, so tension will remain same. Do we understand this? Yes or no? This tension is 2T. T and T up, 2T down. Do we understand? Pulley is massless. 2T up. So 2T should be down. Do we understand this? Then I have 2T here. Now, for this pulley, this 2T and 2T are going to cancel out each other. So we don't have to consider pulley. Even though it is moving, the work done is going to be 0 because whatever force is on the upside, the same force is on the downside. Do we understand this? So we don't have to consider this pulley as even as moving because whatever force is up on the down. So we can just cross this pulley out. This pulley is definitely out because it is not moving at all. Right? Now, there are only two moving things here remaining now. What are those two moving things which are remaining here? One is this pink block and one is this green block. Do we see this pink block and green block? We just have to find out the work done by tension on these two blocks and that will give us the relation between x1 and x2, v1 and v2, a1 and a2. Now, how will I find the work done? We already know the formula of work done is this, cos theta. Now, we'll apply this formula on block 1. Now, remember, block 1, tension is upwards and its displacement we have assumed is upwards. So, what is the angle between the force and displacement? Force and displacement, what is the angle? Both are upwards. What is the angle between force and displacement? Force is upward, displacement is upwards. What is the angle between them?
100%.
Force is upwards, displacement is upwards. What is the angle between them? The angle is 0. We multiply force by displacement and multiply by cos of 0. Cos of 0 is 1. So T, the work done by this tension becomes T into x1. Do we understand this? Yes or no? Everybody, please raise your hands. Do we understand this? The work done by tension becomes T into x1. Okay. Now look at the green block. Green block, tension always pulls, it is upwards. But this block is moving downwards. Force is upwards, block is going downwards. What is the angle between force and displacement now? Force is upwards, displacement is downwards.
-180 degrees, sir.
And what is cos of 180?
-1.
-1. So what is the work done by tension on this block? It will be minus T into, oh, sorry, not minus T, minus 2T into x2. Yes or no? Now remember, the total work done by tension is 0. I have two work done by tension, one on block 1, one on block 2. When you add them, it should be 0. So if I add these two, it should be 0. That means T into x1 minus 2T into x2 should be equal to 0. Yes or no? But T cannot be equal to 0 because if tension goes away, there is no relation. If tension goes away, the strings become loose or string breaks. If the string breaks, there is no relation between them. Then they are free to move on their own. They are only remaining connected to each other when tension is there. If there is no tension, they are free. So tension cannot become 0. So tension cuts from here and we get the relation between the two. x1 becomes twice of x2. Oops. If I had taken, instead of work, I had taken power, I would get the relation v1 is twice of v2. If I differentiate it, I will get a1 is twice of a2. That means if block 1 is moving with an acceleration a or a1 and this is moving with an acceleration a2, this a1 will be twice of this a2. Do we understand this? So at the end of the day, even if you don't remember this entire Ramayana, what you got to do is you just have to write the value of tension and write who is moving up, who is moving down, multiply them and get the relation. This is just for your academic purpose, that you know how it is done. Anyone having any doubt on this? Now, it has taken me 15-20 minutes to explain the entire process because that was the first time. But once you do 2 or 3 problems, just looking at the problem, you will be able to tell me, sir, this is the relation, because you will get used to it so much. Do you understand this? Everyone has written this down. Anyone has any problem? Ask now. Okay. If you have no problem, then I shall give you. Okay, there is no consideration here. I had to make the diagram. I don't have that. Anyone got this? Chalo. Then tell me
Yes,
the
sir.
constraint relation of this. Now remember, whenever you are doing any problem on the constraint relation, what is very important for you to understand is that whatever you have assumed, in that direction only you get the constraint relation. I will explain it to you what I am saying, because sometimes seeing is believing. You have to assume that, see, here you may not know for definite where the block is going to move, but you will have to make an assumption where the block is going to move, and you get your constraint relation according to that assumption. So once you get your constraint relation, you will have to make the equations in the same way. So first of all, tell me how this system can only move in one way. There is only one way this system can move. How is this system going to move?
Downwards.
M2 has to move downward, so let me call that it moves downward with x2. Then what will happen with M1? Then what will happen with M1? Where will it move?
Who's right side?
It will move right side. So we have assumed that this is how the system moves, and this is how you must get the constraint relation. Now, the only problem that you have to do right now, I have not completed the diagram. I kept talking with you, not completed the diagram. So now you have to find the relation between x1 and x2, assuming that x2 is downwards and x1 is rightwards. Remember the assumption. So you have 2 minutes to do this. Draw the diagram. Take your time. Yes, anyone got any answer? Or shall I do it? Or you want more time? No one? Shall I do it? Well, it should not have taken so much of time. If we have taken so much of time, it is of no use. Even if you are able to find out the constraint, you will not be able to solve the question. So there is no use of giving you so much of time. How you are supposed to do this? You have to just draw the tension. Let me start with this. This is T, 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 and this is T. This is T, so this is 2T, and this is 2T. Forget about the pulley. This pulley is not going anywhere. This pulley is not going anywhere. Even this pulley is moving. Tension on both sides are equal. No work is done. You just have to look at the pink mass. The pink mass tension is here and the displacement is here. So what is the work done? By tension on this block, the angle is 0. So work done is T into x1. Now look at the green block. Tension is 2T, which is upwards. Displacement is x2, which is downwards. That means it is moving in the downward direction. Angle is 180 degrees. 2T into x2 into cos of 180, that becomes minus 2T x2. That must be equal to 0, my dear friends. From here, you will get x1 is 2 times of x2, v1 is 2 times of v2, and a1 is 2 times of a2. Why you have taken so long to do this? Is it so difficult? What were you thinking? Anyone got this answer? Why it took you centuries to do this? Taken time of a century. Surya Kumar Yadav would have scored a century in this much of time. You could not solve a simple problem. Anyways, this is a new thing probably. That is why you are not able to do this. I understand this. Where is my thing gone? Everything has disappeared. So, do we understand how this is done? Okay, everyone looks confident. Let me see if I can give you one more question. Anyone has any problems with this? Please tell me. Okay. So do it fast because you have only 1 minute on the clock. Don't get scared looking at the number of pulleys that I am making. I could make 1500 pulleys, but the concept remains same. M1 and M2. I am assuming here that M2 is going down. You have only 1 minute to solve it. Because if you cannot do it in 1 minute, it is of no use in the examination hall. And this is X1. M1 is going up and M2 is coming down. This is the condition given. Can you tell me the relation between X1 and X2? I will see. I was just looking at my database. I was looking at some sheet which has all these questions. I'll try and find it out. And if I have, I'll send it to you. I must be having it, but might be somewhere in the storage compartment. Yes. Relation between X1 and X2. Anyone? Four pulleys here. Two fixed, two moving. Doesn't make any difference to our lives. Huh? No one? Well, the time is over in any case. So this goes down as a homework problem. So try and do it. And
E1 is equals to 4v2.
yes, bacha?
E1 is equals to 4v2.
V1 is equal to 4V2. That is correct. V1 is equal to 4V2. That is correct. How many of you got this? That is correct. V1 is 4V2. We will discuss this problem and I'll see if I have a sheet there with these problems. I'll send it to you. The more the number of questions that you do, the better you are going to be. You just have to look at what is T there and what is tension here, just that, nothing else. You get used to it, you will be doing better. So I'll see you in the next class. Take care. God bless all of you. Bye-bye. We'll solve this problem in the next class. Don't worry. For those who could not do this. Take care.
Yes, sir.